But before we get into that, my name is Abhinav Jayanty. I am a data engineer from Scotland, so originally from Edinburgh, but I live in Glasgow now. So we have some wonderful things in our country. Obviously, as Olivia mentioned, we've got very good whiskies as well. But I'm a data engineer and data consultant. I'm working currently for a consultancy called Quorum. I've been there for about 3 years, and we do anything from managed services up to BI consultancy, AI, all that sort of stuff. And at the moment, I'm working on a security project as well. So a little bit of everything, as I think most data people are, but my core lies in analytics and data engineering. And a few things I've done a few of the certifications and some of the things that are available there, especially for Fabric. And then also I do some ambassador stuff for Redgate, which is quite cool. So Microsoft Fabric, I was having a conversation with one of my colleagues the other day about how it has now almost been 3 years since the announcement of Fabric and kind of 2.5 years since GA. And I think it's very mature in some places now. There are still some new features and functionalities that are, let's just say, still being refined by Microsoft. But obviously, it's the only thing that anyone can talk about these days in the data space. And my niche, I would say, in Fabric, what I present mostly on is the real-time element of things. So very quickly, if people are able to kind of just use the chat, it'd be good to get an idea. How many people are familiar with real-time concepts, IoT, streaming, event hubs, all this sort of things? How many people have used these products before? I can give it kind of a minute for the chat, but this is to test that everybody is still paying attention. But basically, I think what is common is I usually find that a lot of people either don't have the interest in streaming things because they're like, it's a very niche use case, or people are like, okay, I want to do this stuff, but it's always been so difficult to provision event-driven architectures in Azure with event hubs and service buses and queues and grids and topics and messages. And it's a whole different type of architecture to get used to, especially if you do data engineering with batch, usually. But a lot of what I say to people is that you have to think about data in terms of, is it time-based or is it schedule-based? So time-based meaning it's kind of critical at the very point in time where you capture that piece of data. So in the physical world there on the left-hand side, you'll see some use cases, a lot more in manufacturing, energy, retail, where they want to know and report on things immediately. So if I have an issue on my manufacturing line, I need a sensor to record that and send it to me straight away so that I can take action on that. If I have a stock trading application working for a financial services company, I want to be able to track the prices of stocks and trade them in real time. I don't want to have to, I can't run a batch process for that because I'm not able to react to things quickly enough. And a lot of what I think people will be a lot more familiar to and not even realize it is the time-based data from the digital world as well. So on the right-hand side there, audit logs, activity logs, and access logs are all time-based data. These are high-frequency events that are sent in the form of JSON or XML messages from servers, from Windows events. In Azure, you have all the activity logs and everything that happens there. You need to be able to use those logs to understand what is happening in the organization and what is happening with your Azure environment. So that all comes down to the fact that you have high frequency, high throughput data. A lot of the times it's semi-structured as well and can be just free text, but you need to have low latency and you need to avoid schema drift. So a little bit of what we're going to talk to today is that we need solutions to be helping us to take control of this data because it is actually very, very valuable and a lot of people don't realize it. And also, I think this graph is even a bit outdated by now, but this is one of the Microsoft graphs talking about how the amount of data that we're producing every single day across the planet is into the exabyte range every single month in terms of events and high frequency logs, how much we have to ingest and have queries that are optimal to run across all that data every single day, how many events we process, and also what's very important is not losing any of that data from source to destination. when you're working with real-time data. So a lot of what we're going to talk about today is going to be talking about how Microsoft Fabric achieves that with real-time intelligence. So what's on the screen right now is the current offering. If you look under Azure's data platform offerings, what does Azure let you do with data? So you'll see a lot of things here that are very familiar. So SQL databases, Data Factory, Databricks, Power BI for data exploration. All of these are common platforms that we have all used in some way or another if we work in the Microsoft data space. But you'll see at the bottom there, real-time analytics is this big category where a lot of people aren't really familiar with a lot of the products that are there. And as well as Data Explorer under data exploration there's a few things that are quite hard to understand and are quite niche for the use cases that they offer if you don't know what you're doing with them. You might know that Kafka is some sort of standard for messaging, but you're not able to actually analyze it or do anything with it. And my point about event hubs and stream analytics as well and log analytics. This is what Azure offers for real-time processing. What real-time intelligence and Fabric does is it simplifies that a little more. And what you get is essentially the enterprise platforms that existed before. So to quickly go through these, event hubs is you can think of kind of like a bucket for all of your events coming into Azure. So this is where you send them to. This is where you collect them so that you can then go off and do something with them and send them to something else. Event Grid is a push-based source, so more for notifications or anything that you want to be doing for alerting and monitoring, you would use an Event Grid. Stream Analytics is what allows you in Azure to transform and process events, do any filtering, deduplication, all the sort of stuff you would do in Stream Analytics. And then Data Explorer is the platform as a service PaaS solution for writing queries and creating dashboards on event-driven data. But Fabric combines all of these, and then it brings the best things about Fabric on top of that as well. So you have one lake, so a single copy of data in the Delta format across your entire Fabric tenant. The data activator, which allows you to react to any changes in your data. We can talk a little bit about that later on in the session. And Power BI for exploration as well. You can still use Power BI for exploration of real-time data, which is very important as well because things like streaming data sets have been deprecated now in Power BI. If you want to do anything with streaming in Power BI, the best place to do it is going to be from Fabric Real-Time Intelligence with Power BI then connecting to it. And that brings you a fully integrated experience, no code, low code, software as a service under Microsoft Fabric, as we are all used to over the past few years, as I mentioned. So this is the stack of what real-time intelligence offers. You start from ingestion, you're then able to store and do analytics on it. Obviously, AI and Copilot is available across everything these days, so you have that. But then for visualizations, you've got your dashboards, and then the rules and actions that I talked about as well with Activator. All of that sits on top of the real-time hub in Fabric. This is where everything related to real-time intelligence is situated. Any questions on that introduction to real-time intelligence before I move on to the components that make it up?
There currently are no questions, Abby.
Yep, all good. Sounds good. So what I thought I would do before a quick demo today is introduce you to the basic resources and the components of real-time intelligence so that you have a little more context when we go over into Fabric to talk about it. So first we have to start with storage. Where can we actually store our events that are landing into Fabric? And this is done in a thing called the event house. So Microsoft is very fond of calling things, you have warehouse, but then you have lake house and event house and all sorts of different houses now. But event house, in the name, it's essentially just the optimized storage location in Fabric for event-driven data. And then under that, you have a collection of what are called KQL databases. So you can think of this as the event house being the logical server and the KQL databases being the actual storage locations where you have different tables of event-driven data. So not too different to anything you've seen in terms of storage in any other solution. And as I mentioned, the real-time hub, which is the single place for all data in motion. which is another term for data that's constantly moving and changing in Fabric. And this is where you have all your streams, but also you can store things like Fabric events and Azure events, which are being developed on at the moment, but I'll cover those later on. So you have your storage, but then we need to move to how we ingest and process events as well. And to do that, the core of it is the event stream. So the event stream is a part of the functionality that allows you to connect to various sources natively and also third-party sources. It's built on all of the architecture that's used for event hubs as well. So it's not like it's something brand new. Microsoft has taken the back end and the libraries and everything from Event Hub and repurposed them for event streams in Fabric from Azure. So the shift from that, if you are someone that uses event hubs, which is why I asked the question at the start, event streams will seem a little more familiar to me in how they work and what kind of quirks they might have. And it offers a no-code experience as well to transform and clean data. And then you have the Activator, which is essentially a way for you to monitor data in your Power BI reports, but also event streams for any changes, patterns, and anomalies, and then to go on and take actions based on that, such as alerting, but also a lot more now in terms of orchestrating a lot of things in Fabric as well. And finally, for analysis and visualization in real-time intelligence, we've got Power BI reports, which I said are still supported, so you can build Power BI reports directly from Event House data. And this is better for something where you're doing a bit more long-term static analysis of any of your data that's been ingested. And you're still able to build dashboards and reports on the data that's been ingested using real-time intelligence. But now you can use things like direct query mode in Power BI to have a Power BI report that stays up to date a little more often because it's now connected to the real-time source. We have what are called KQL query sets. So one of the main objectives for this session as well is to give the attendees a bit of an understanding of the Kusto Query Language, the KQL. And that is how you can run any queries across your KQL databases within real-time intelligence. But it offers a lot more as well. You can do inline visualizations, built-in anomaly detection and machine learning, geospatial analysis with a lot of functions because KQL is completely open source. And in my opinion is one of the best things that Microsoft has developed in recent times. And people are often shocked at how much it's used across the board, but how many people don't know about it. So I would think there will definitely be a few things that people pick up from KQL today that are quite exciting. And then you have your real-time dashboards. So these are modular dashboards that you can populate by running these KQL queries, and you can set them to have continuous and automatic refresh. So the Kusto Query Language, to give you a bit of background, I've not got a slide on it, but essentially, long story short, about 12, 13 years ago now, Microsoft developed it internally as an engine for processing all of the millions and billions of rows of logs that were created from their product telemetry. So the Xbox teams, the Skype teams, all the internal Azure teams when it came to that. They have the Kusto engine internally, and then in 2019 what they did was create it as a product that could then be offered to consumers to do the same, to do analysis on billions of rows of telemetry data in real time. And Kusto and the engine behind it for log analytics is often one of the first things that's deployed whenever Azure goes to a new region. Just something I heard from someone from Microsoft, which is quite interesting, is that it's such a core part of Azure. All of this architecture, all of the way that we analyze things here using the Kusto engine. So it's quite important that we have an understanding of what the Kusto query language is. And a lot of people often say, oh, do I have to learn a new query language now? Do I have to forget SQL, forget Python and everything? I have to learn this new language called the Kusto query language. You'll often find that it's actually a lot more familiar than you would think. So what I have on screen here is a standard SQL query, T-SQL query that I think most of us will have run many times across our lifetimes. We've got a select from a table. So a select to bring the columns that we need, top to limit our result set so that we're not reading everything from the table. Our from is to specify which table we want to read from. Our where is to filter it down for what we want our result set to be. group by for any aggregations that we want to do, and then finally you would do an order by to have your result set in an order that makes the most sense and is most relevant. And I think this is something that everyone can agree on, or 99% of people can agree on, because one person might say they write SQL differently. But for the most part, this is SQL. KQL simply follows an order of give me the table, do my filter, do my aggregations, do my ordering, select my columns, and then limit them. So you might have already spotted that the order in which a KQL query is written is very, very similar to a SQL query, but with one key difference. You specify the table first, then you filter it, then you aggregate, then you order, and then only do you select the columns that you actually want to project and present in your result set, and then you do a limit. And a lot of people might know this as well, is that the order on the right-hand side is actually how the SQL engine, how the query execution engine actually reads your query and processes it, is that it always starts with the table, does the filtering, aggregations, ordering, and then picks out the columns. But the way we write SQL is the other way around. We have to first specify the columns. So for that reason, I actually quite like the way Kusto works, is because it has the context as soon as you write the table. Whereas before we have to pick our columns from a table. I think the first query that anybody will run with a table that they don't understand, the very first query they're going to run is select top 1000 star from table, is one of the default queries that you'll run on any new table. KQL makes that a little bit easier, because once you specify the table, you're then able to immediately see the columns, and the IntelliSense has all the context it needs to help you build your Kusto query. And I can show that in a practical example as well when we move over to the demo. So to give you a quick example of what a SQL query would look like versus a Kusto query, on the left there, all we're doing is selecting a column, selecting a count from our table, doing a filter, and then a group by. So I want the count of everything for column 1, wherever it says Ireland. So only for Ireland, give me an aggregated count. For the Kusto query on the right-hand side, we essentially have give me the table, give me the filter, summarize is what the clause is, what the operator for aggregations, count of calls is your alias, and then equals count by. So give me the count by column. The way you write the query is a bit more simple as well. And I've basically just put a box around the project at the bottom there to say it's not actually, you don't need to tell Kusto to project that column, because once you get to line 2 of that query, it knows what the result set is. It already knows how many rows and columns it's going to present to you. So you don't need to even write the project or the select to receive the columns that you're looking for. So a quick recap on the Kusto Query Language before we move over to the demo is, on the left there is your order of syntax. And it is very simple and easy to learn. There are a lot of resources, which I'll tell you about later on. And there's a lot more powerful functions that can do things such as extracting items from JSON arrays, and it's extremely performant across billions of rows of logs. And there's lots of powerful open source functions, which I talked about there. So what I'll do is I will switch over to the demo, over to Fabric. And if we and so at this point, it is only going to be demo for the rest of the session. So any questions that anybody has, feel free to just put them into the chat or raise your hand, and Olivier will be able to moderate. But what I'm going to do is I'm just going to show a quick end-to-end solution that I've built in real-time intelligence in Fabric that you'll then be able to replicate or go off and look at the documentation to figure out how to create a similar solution. So basically what we have here is some of the components that I talked about. So what we're going to start with is a notebook here. So this is my source. So what I've chosen to do for the sake of this demo is create a Python notebook to generate my event-driven data. Usually you would hook up to something like a Event Hub or one of those native sources that I talked about. So actually what we'll do, since we have a little more time, is I'll show you the real-time hub. And yes, as Olivier said, I don't bite at all. And this is one of the things that I do enjoy spending a lot of time talking about. So yeah, I'm more than happy to answer any questions. But what you can see here is you have a whole bunch of data sources So sample scenarios out the box that give you that functionality in events, but we have support for Amazon, Kafka, Cosmos DB, Event Hubs, SQL database. All of these things are available as sources that we can connect to with the event stream. And you'll see here that we have a few things such as capacity overview events or Fabric workspace item events. These are internal events created by Fabric that you can then hook into and bring in as a data source and start to build any reports or functionality on top of them. I see the question there, where's the extend syntax used for? So I had it on the slide there, the extend. I'm not going to spoil that yet for you because I will show it in the KQL demo. But that is extend. To answer the question, extend is a way of creating a new column in your result set. But I'll show a practical example of that very shortly as well in the demo. But these are just an idea of some of the sources that you can connect to, and they're constantly changing these sources that you can connect to, and the support for all sorts of third-party things. The Azure ones are quite good as well because it essentially means you can connect to, if you have a database that supports change data capture. So, for example, for SQL DB, if you have it at a certain tier or whatever, you are able to hook into the change tracking functionality and then capture any changes in real time as they happen on the database and bring them into Fabric. But what you need to do with any of these sources is bring them into an event stream. Oh, okay. I didn't realize the demo wasn't sharing. Apologies.
Good catch.
Yeah, thank you very much, because I was just about to jump into the demo. Is that better now?
Yeah.
Sorry there, I thought it was on the same screen, so I thought it was just sharing the screen, but I was apparently sharing the window. No, thank you very much for that catch. So, okay, sorry, apologies. Very quickly, we'll just go through this again. So these are in the real-time hub in Fabric. So Fabric homepage, real-time on the left here. So this is where we can connect to all sorts of data sources. So the samples, Fabric events, and any of the third-party sources here as well. And the database change data capture that I talked about here, you can connect to. But the Fabric events are really interesting because any jobs you have, so any notebooks and pipelines that finish, the status of them you can capture, because I'm still quite not happy with how the monitoring works in Fabric compared to how I can use log analytics in Azure. But doing something like this and building something in real-time intelligence is how you can create something that's a bit more efficient and intelligent. Yeah, that was a very good catch before I actually started doing lots of things in the demo and going crazy. So before we get started, that's good to point out. Thank you very much for the people in the chat. So what we'll do, as I said, to be able to bring these events into an event stream, first of all, we need to go to our workspace and we need to create an event stream. So I have something here called ES post stream, and you can see here that currently I'm pulling from a custom endpoint as well. So you can see here, you can connect to those data sources that are there, sample data, or you can create an endpoint that the event stream has that you can then send events to from any of your custom applications. So this is what I'm doing here. So I have a Python notebook. For the purposes of this demo, I've just created to create fake JSON messages. So I'm using the Event Hub library there and the Faker library for my data. And this is my connection information just using SAS key authentication, but I believe you can set it up with all sorts of other types of authentication as well if you want to. But essentially what I thought I would do was I like to, Olivia might know this as well, I like to tailor my demos to the audience who I'm speaking to. So for example, if I was in Seattle, I was talking to, the last demo I did there was Seattle bus data and talking about the fish reports and everything that they have. In Vienna, I was talking about classical music. But for Belgium, I thought, what do I love the most? And so I've been to DataMinds Connect a couple of times, the event in October. And the one thing I always look forward to, apart from catching up with Olivier, is beer, and Belgian beer specifically. So I thought, so my go-to demo for this sort of stuff is social media messages and fake social media messages. So I thought it'd be quite fun to create some social media posts, essentially, that we're tracking as if we're some sort of marketing agency or website. for these distilleries, and we have a lot of people tweeting or posting on Facebook and LinkedIn about their favorite Belgian beers, like for example, a Gouden Carolus whiskey infused, or a Duvel, or a triple, and all this sort of thing. And it's going to be completely randomized between, so for example, an example would be, I tried a Duvel for the first time, and it was an immediate life upgrade. So these are the messages that are going to be coming into real-time intelligence. And we need to be able to track them, analyze them, and then build reports off of them as well. So I don't want to start any debates in the chat about which is the best beer out of all of them, but I've tried a few of them, and I can confirm that they're all better than beers that I can find here. So yeah, I always have a good time with beer in Belgium, as Olivier will know as well. But all we have is a function at the very end here to essentially randomize that, build up our message. And I'm doing some JSON nesting here as well on purpose, because we can use real-time intelligence and KQL and event streams to parse that and pull out the important things there, and then sending to our event hub. And I just have some things there to keep it all running smoothly. So the session shouldn't be too slow to start up. And again, as I said, any questions, just put them into the chat. But yeah, maybe don't start a debate on what your favorite beer is. That can happen later. But we'll wait for this to start up, because obviously the session died on me again before I started the demo. But we're good for time, so we have plenty of things that we can show here. Yeah, I was actually thinking of I was telling somebody about the Gouden Carolus the other day, Olivia. They were very intrigued when I said there was a whiskey infused one, but yeah, I think we'll stick to these. So you can see here. So now we have username. Here we have their fake IP address, the platform in which they posted on. This one is the Lindemans Creek beer, which I quite enjoy as well, the cherry one. And then the language that they're all tweeting in at the moment is English, they're posting. So if we go back to the event stream, we're going to start seeing these events come through with a little bit of a delay. But what we can do here, if we just wait for this. And this is the worst thing about doing demos for real-time things, because you do still have to wait for things to land and process and everything. But to recap what I've done there, I've got a notebook here that's creating all of these messages, and it's sending them to the event hub, which I specified up here at the top with the connection string. And you can see here, it's actually still using the service bus endpoints that are working behind the scenes. So Eventstream and everything is a brand new name, but Microsoft is still repurposing all of the backend they use for any of the messaging things in the Azure world as well, which is good. Hopefully we have some events here soon. Just take a minute. Yeah, perfect. I was taking a little too long now for my liking, but you can see here, so we've got the user data array of the JSON there. So this is nested information of username, IP address, and platform. So obviously we want to be extracting this as well for our data when we land it in the destination. We've got the topic that they talked about, which is passed from the source, the actual text, and the language. So what I'm going to do here in the event stream is going to show you some of the functionality, the low-code functionality that I talked about for transforming events. And what we can do here, so you can see that you can use predefined operations where you can filter and aggregate and join and union from different sources that you send into the processor here. So I can have multiple sources. If they're all following a similar schema, I'm able to ingest them and then merge them essentially for my destinations if I wanted to. I believe the support is up to 11 sources and destinations for one event stream. But if you have another different type of source or a destination, you just create another event stream that you can manage differently. Pardon me. And I'll show you an example of that later as well. But what we need to do here is just add a operator here. So what I want to do is use this thing called manage fields. And manage fields, essentially what it does is it allows me to check all of the fields that are being sent into it. I don't know why that's just, let's try that again. So this is operation in manage fields. If I go add fields, so if I do add all fields here, you can see these are all the fields that are coming in to Fabric at the moment. And you can see here that timestamp is at a string. That's okay for now because people might ask, why is a datetime not stored as a datetime? But for event-driven data, when you have, it's a column store index as well, so you don't need to essentially give it any sort of strong typing on that sort of stuff. It sits a string and then it's indexed in the background and everything for you because you're reading the entire column set at the same time. So it's a lot more performant to just leave kind of the automatic fields here, usually I found. But you can see here that the user data is a table, which essentially means that it's a dynamic field. It has more columns underneath it. So what I want to do is I want to expand that. So if I go to add field here, what manage fields allows me to do is expand that user data field and then pull out things like username, IP address, and platform as separate fields now. So if I was to add that there, we've now just used manage fields to pull that nested JSON and bring new fields into the result set here. So if I save this now, I don't know why it's just stuck itself over the left. It's never done that for me before. You can see here that we now have quite easily extracted the username, IP address, and platform. So that was quite a simple example, but often with events and messages, you have a lot of nested JSON. You might even have like third or fourth level nesting as well. And you can use this manage fields operator to be able to extract all that information and send it to the destination. So what we need to do here is now give it a destination. So I have already configured an event house to store these messages. Yeah, Fabric's being a bit temperamental today, which is annoying. But what we'll do is, that's great, never seen that before. Actually just refresh the page. Seems that Fabric is not ready to go back to work this year in 2026 yet. Try just closing and going back into Fabric, which is not ideal. Yeah, so we didn't save, we didn't publish the topology there, but what we can do is we can come back into this and quickly add it back in. So manage fields. You need to make sure that it's connected to the processor here so that it can then feed all the fields in. We're going to get rid of user data, add the fields, go to our user data here and bring in the username, IP address, and platform. I hit add and save. We then give it a destination. So the destination here that we're going to have is event house. So I'm just going to call this my hosts destination in the event stream. It's in my same workspace. I already have an event house called Event House Messages here, but I do need to create a new table for these because currently there's no tables in the event house. So what I'm going to do is I'm going to do that from here. I'm going to call something called raw posts. And this is where I'm going to land all of my data that's coming from this event stream. So if I save this now and connect these two, everything suddenly goes green. I'm good to publish it. And once we commit this and publish it, the event house can now start ingesting all of the data from the event stream. So we finally got there. Fabric woke up in time for us to do this, which is good. It definitely didn't do that when I was testing this before the user group, so it's very fun. But it's loading here at the moment, which is why it just commits the changes and creates the connection to the event house. Once this goes green and says it's enabled, we will start to see data ingested into the event house. So any questions on event stream while we're here?
Still no questions.
Still no questions, perfect. That either means that I'm doing a really good job or people are doing something else.
They might be wondering though what your favorite Belgian beer is though, but
I'm very diplomatic usually when I give my sessions. I don't I mean also the fact that the answer is all beers are good in Belgium. So we'll just refresh this to take a look, see how it's doing. What we can do is I can show you a little bit of the event house here as well while we wait for that. So in the event house overview here, what we have is almost kind of just some details of our logical server, as I said, for our event-driven data that's coming into Fabric. So that's a question there. Would there be a minimum of Fabric capacity SKU that you would recommend for real-time workloads? Great question. So I have now been presenting on real-time intelligence for about a year and a half now. And for most of that time, I was using the F64 trial SKU, so I didn't, I wasn't monitoring that heavily because there was a lot of things I was doing. I ran a full day training session for 20 users back in March, where they created a notebook similarly that was running throughout the day and ingesting the events, processing them into Event House, and then using the real-time dashboards. I think we found that it was using something like around 4 capacity units per process. So per user at the time, but essentially per process. So I'm running this at the moment on an F8. This is my personal developer capacity. So at the very minimum, you are able to do this on an F4, I would say, but that means that you're not going to be able to do much else in Fabric. So at the very least, I think what I recommend to clients as well that are doing something with Fabric is that for an organization where you have more than 1 or 2 people working on something in Fabric, F8 seems to be the best recommendation to make for that. No, but that's a really good question. Yeah, and the real-time thing is hard to predict as well because it's something that's ongoing in the background. But there's a lot of compression and everything that goes on in the background to ensure that it doesn't get out of control in the capacity. And you can do some smart things with storing and everything here. So what we can see is we can see that our destination is active here now with the green tick. So if we go to the event house, if I go into my KQL database, we should have a table here called raw posts. And you can see that we're starting to ingest some rows already. And this is our preview here of the data. I'll make this full screen again. It's usually just a little nicer to see. And we can see here, these are the records that are currently landing as we speak into our table called raw posts. So let's go over to a query set where we can start to do some analysis on this in the roughly kind of 15 minutes that we've got left. So I can look at this. I can say, give me all the data that was ingested in the last hour. So obviously this is going to be quite recent in the timestamp here, but if I was to do 1 minute here, you can see we've got 84 rows that have landed in the last kind of since 6:13 UK time. So what we can do in KQL is use this take operator. This is essentially just saying, give me any random 100 records from this table. And this is what we would usually do to say, give me a sample of the data. So instead of select top 100 star, you can just say take 100. So it's a bit nicer, it's a bit more concise to query with KQL. And you can see here, so we've got a summarize. So we're going to do a count of all the ingestion times in intervals of 1 hour, which is what the bin means. So when you bin something, it's binning all your records into the given time interval here. So if I run this query here, it's going to give me all the ingestions per hour. And I can also break this down into, so again, if I do this for minutes, just because it's only been running for the past few minutes, you can see here we're currently receiving about 85 messages every minute, which is very low and on purpose as well, because I don't want to hammer this. But you can start to see that it does start to get consistent there. And you can do something called get schema as well, which essentially gives you the schema information, so all the ordinals, the types, and the column types there as well. I'll just very quickly fix this so that I don't have any other issues. And what we have here is to show you that you can actually still use native T-SQL on Event House data in these query sets as well. So it's not just Kusto that you use. I can still run a select top 100 star from posts and get the same result, but it's going to be much more performant to use the Kusto query language in comparison. Obviously, we're not going to be able to do much of a performance comparison now, but where something in Kusto takes kind of 0.2 of a second, I've seen a SQL query take up to a second with this sort of stuff. But what we can do is we can put an explain clause on top. You'll see as well that the SQL doesn't have IntelliSense the same way that Kusto does if I was to do the same sort of query there. So what we can do is we can put explain here. And what explain does is then give us the Kusto query that we need to run to be able to, it translates the SQL query essentially. So if I was to do select count from raw posts and run this query, it's going to work. And I can alias it. I can do everything that I can do with SQL. But if I do an explain on this, it's going to give me the Kusto query to run for that. So summarize count, type my count as an int as well. The explain functionality is very well behaved with types and things like that and aliases for columns, and then do a project. But as I mentioned, you don't even need to do the project. You can only do this section and it will run absolutely fine. There. And we've got some summarizes here to essentially do some queries that I talked about with the aggregations. So you can just, it's quite simple to get a count by column. It's literally just count function by platform for the platform count. So at the moment we have quite an even spread across everything. And if we were to do a summarized count by topic, currently we don't have many people talking about the whiskey infused Carlos, but we have a lot of people. I think what's most popular at the moment is the Hogarden. So we can do some analysis on that there as well. But so Olivia, the question that was there from before, the extend syntax. So as I mentioned, this is if we have, so this is an example to show you how you would do it with Kusto code, what we did in the event stream with the manage fields. So what we did there was pick the field, use the no-code viewer to then give us the correct columns. But if we were to do that in Kusto Query Language, sorry, the Teams thing is just in the way. I would take the raw kind of user data JSON message, and then you're able to just travel through the nesting with the dot syntax as you would for JSON. So user data dot username becomes this extend column. So I'm not going to show this just now, obviously, because I've landed everything in the correct format with the event stream already. But if I was to do this, I would be able to change the types and everything just by doing this toString as well. So Kusto Query Language is quite simple and quite easy to learn. And what we have in the thing, as I mentioned, is some custom functions that are built for Kusto Query Language. So KQL is used a lot more in the security products that Microsoft has as well. which are used for finding any malicious activity. So for example, this geo info from IP address is because if you have a real world scenario when you're ingesting security logs from the IP address, you're going to be able to get the geolocation of where that attacker is maybe coming from. And that gives you the longitude and latitude of that user. So what I'm doing here is all I'm doing is extend lon as a real column using this function on the IP address column that we have already. So if I do this now and project IP address, in raw posts, we only have the IP address at the moment, but now we also have the longitude and latitude for that. And what we can do is we can create a function you can think of as kind of like a store procedure almost in Kusto to do that for us. So what we can do here is we can take the raw post table. We already have these things from the JSON. And then what we're going to do is we're going to project that timestamp, text, topic, username, platform, IP address. But now we also persist the latitude and longitude. And if I do this in a function called enrich post data, what I can do then is read this function the same way as I would as a table, but I'm able to execute it and receive those extra columns that I've added in from here as well, which is very useful. So now if I look at my raw, we don't have any latitude and longitude. If I look at the enriched, we do there. So it's all fine and well that I'm ingesting everything in here and I'm using the function to create those new columns, but I want to persist that somewhere. We want to almost do like an enrichment and store it in a different layer. Kind of if you're doing a medallion, you would go from bronze to silver. Here we're going from raw data to enriched data. So I want to persist all of that in another table called enriched posts. So again, very basic functionality here, but if I want to do something else, I can do that in the function. So first of all, we need to create a new table to be able to store the new data that we're landing. So I can do that. And that's just as simple as going create table and giving it all the correct column information there. But at the moment, this table is going to be empty. There's going to be nothing in there. So what we have to do is something called an update policy in Kusto, which essentially says this table now has a policy to say, from the raw posts table, use this function to then ingest into that post table there. So if I flick this now, what's wrong with this? Query schema does not match. I know what I've done here because I did have the date time there, but I didn't have it's coming in as string there. So we'll just fix that very quickly. For the sake of this demo, it's the types for the date times doesn't really cause issues. So you can see here that we've now got the update policy is created. So as and when we have data ingesting into the raw table, it's also going to show up here having that function applied to it. So we'll give it a minute or two, and then we can see the data ingesting into that table there. But we can come back to that because what I can show you is still using the raw table. I can show you some of the inbuilt visuals that you're able to build on the Kusto Query Language. So we have the same query here, the summarized count by platform that I ran before. So this is all the count of each platform that people are posting on. All I have to do here is add this render clause. If I do render bar chart, I suddenly have a visual representation of that as well. And you can do all the good things like changing your axes, titles, legends, colors, labels, all that sort of stuff through here. But this is very, very useful for showing, just doing analysis, being able to run those queries and visuals in line with these query sets is a very good functionality of KQL. We'll take another look just in that enriched posts table to see if we're ingesting stuff in there. And you can see here that now we have a persisted table in the event house that now has the transformed data. So once you do this, what you would typically do is then you can set a policy for the raw data to be purged more often. So maybe give it like an hour of retention. You can do essentially a soft delete of the data, and then you're not being charged or processing any of the raw data that's landing into Fabric, because it's all going straight into the enriched stuff. You should land everything into a raw table just to conserve the message, just so you don't lose any of the data there, but you can then drop it once you've done your transformations and applied the function and the update policy. So we've got maybe 5 minutes left. So what we'll very quickly do is create these in a dashboard from the enriched table. So I just had a few other visuals here that I built, just for the sake of it, to wind up any data visualization purists. We've got this in a pie chart, and you can see here that, we have a good share for Duvo and Hogarden in the posts that are being made, but we don't have much here. So yeah, of course, what we can do here is we can create this as a bar chart as well if you want to be boring. But yeah, sometimes I just put pie chart just to tease some people in the audiences. And we can also do analysis over time. So we have what we can do here is time chart of, I don't know why they've been, it's because we've got a timestamp. That's fine. So what we'll do here is I want to see who are my users that are talking the most about beer, because I can then maybe run some promotions for them. I can send them some free cases of beers. So at the moment, we only have these users that are only just doing one each, but we can do that sort of analysis if we wanted to. And we can also create a map of the world to see how people are talking about Belgian beers. So obviously some people in Africa, and because these are fake IP addresses, obviously we don't really have many real data points. Surprisingly, nobody in Belgium wants to talk about Belgian beer because they are gatekeeping, probably. But what we can do, so let's go back to our topic bar chart. Was quite good. We had some useful information there. So I'm going to pin that to a dashboard. I'm going to create a new dashboard called beers in the same workspace. And you can see here that we've just pinned a tile using that query. We can edit the tile. We can edit the query that it uses. So count by topic here. We can apply those changes. And it's for the time range of last hour. But what we can do is when we refresh this, we do see that changing as and when we're ingesting data. But I don't want to click this refresh button automatically. I want to be auto refreshing this. So if we enable auto refresh here, I want continuous. The refresh rate is going to be continuous as well. It's now refreshing for me, and I have my real-time dashboard showing me the ingestion of data as and when it's coming in. So very quickly, just to show the functionality there. So we'll save that. We'll just pin one more visual to the dashboard. So let's do count of topic. Oh, sorry, that's the one we just did. Let's do platforms and keep it as a pie chart just for the fun. To an existing dashboard that sits in this location. Data pinned to dashboard successfully. And you can see here now that I have, so I don't want Copilot at the moment, but I can pin these visuals here and they are going to ingest and update as and when we have data ingesting. So that's a very, very quick and dirty way of showing how real-time intelligence works end to end in Fabric. And you can create alerts on these for certain thresholds. So if I want to create any promotions or whatever, I can go from that here. I see a question in the chat. Any suggestion for hands-on hobby project on real-time data in Fabric to get hands-on? I love this question. And Olivier, if you don't mind, we'll take a minute or two over to go back to the content, because while I answer the question, because the whole reason I ended up coming into this whole KQL real-time niche is because I am a massive fan of Formula One. Actually, I just show, so it's one of my personal passions. I have F1 car on display all the time. But what got me into using Kusto and everything in the Azure world is essentially, I saw that I could output telemetry from the F1 game into something like real-time intelligence, and I hooked it up. I created all the telemetry from the F1 car, brought it into Fabric, and then started doing real-time dashboards of my telemetry from the game and everything. And there's some really cool, if you ever go to one of the Microsoft conferences, the really big ones, like Ignite or whatever, Microsoft has a stand with racing simulators that are outputting to real-time intelligence all the telemetry. So that's a really good hobby. If you have any home automation things, so sensors for temperature, I know that, so my energy provider here in the UK has an API key that I can use for my energy readings. So I could bring that into Fabric, I could ingest that data and then say, alert me when some thresholds cross certain, if I could create a pipeline, say once it crosses this threshold, once it gets too cold in the flat, send something to my other smart home system that turns on the heating or something. That's the whole concept of real-time intelligence and event-driven data is not waiting around for reacting to things. You have to have the information now and you have to act on it now. So any events that are created in your life or also at work, real-time intelligence and Activator can be really, really cool to automate some of that. So that's the demo. What we'll do, and I'll hang around for questions, or Olivia's put my LinkedIn information there as well, so we can talk about that. But great question there, the hands-on hobby thing. As you can see, I've suddenly gotten much more excited talking about it because it's one of my passion points about Fabric as well. So if we go back to the slides, and I'll share that again. Hopefully everybody can see the slides here.
Yep.
So that was our syntax there. All I have on the slides here to show in the end is essentially how you can learn some of the stuff that I've just shown you here as well. So we talked briefly about Azure Data Explorer. I'll put a link in the chat. So Data Explorer .azure.com, I believe, is essentially the platform as a service version of real-time intelligence from Fabric. So you don't have any of the connections to Fabric. You can't connect to Power BI or things like OneLake and all that Activator sort of stuff. But Data Explorer in Azure allows you to do the ingesting and the KQL and dashboards element of what I've just shown you. And the great thing about that is that you do not need an Azure subscription to do that. You can create it just with a Microsoft account. So I'm thinking that URL is correct, but I can double check that as well. The Kusto Detective Agency is really good because it's problem-solving exercises that you need to write KQL to solve. And part of that is getting you to create the Data Explorer cluster. So the free cluster allows you to do things to a certain limit, obviously, of compute. So that's quite good. mthlearn documentation is very, very good for Kusto. As I said, it's open source, so it has a lot of the information on the queries. It had a cheat sheet for SQL to KQL as well. And then finally, there's a website called kql.how, which is maintained by a good friend and collaborator, Brian Bonk from Denmark. And that essentially has a whole bunch of things on it as well, on just like a how-to guide of using KQL. So yeah, unfortunately ran a few minutes over time just with some Fabric issues that we had, but it got up and running in the end, so we're all good. So thank you very much, everybody, for coming along to the session.